Here's problem 3816. Monochromatic light from a helium neon laser, wavelength 632.8 nanometers, is incident on a diffraction grating containing 5,000 lines per centimeter. Determine the angle of the first order maximum. If we have a diffraction grating, then it's true that d sine theta is equal to integral number of wavelengths. D being the spacing between the lines on the grating, theta is the angle to the maxima, and m is an integer. In this case, we're given the number of lines per centimeter. Let's call that little n. So that'd be the number of total lines per length, and that is equal to 5,000 lines per centimeter. Well, the spacing between the lines is actually going to be equal to 1 over little n, which is going to be equal to the total length divided by the total number of lines, which is going to be equal to the total length divided by the total number of lines. And that's going to be equal to 0.01 over 5,000, which is going to be equal to 2 times 10 to the minus 6 meters. So that is the distance between each line on the grating. Hence, rearranging our first equation, the angle to the first maxima will be the inverse sine of m lambda divided by d. And that's going to be the inverse sine of our first maxima, m equal to 1. Our wavelength was given as 632.8 nanometers times 10 to the minus 9. And we just calculate the spacing between lines as 2 micrometers. And this is equal to 18.4 degrees. So the angle to the first order maximum is 18.4 degrees.